Alright, so these first two problems involve us converting between particles. So particles could be something like atoms or molecules or formula units or ions or really anything like that, and moles of things. And whenever you're converting between moles and particles, you use Avogadro's number. So Avogadro's number is usually abbreviated capital N subscript A, and it's equal to 6.02 times 10 to the 23rd. And as I said, that's a conversion factor that allows us to go back and forth between particles and moles. So in this first problem, number 97, you're told that you have two beakers. One of them contains 0.250 moles of copper 2 plus ions, and the other contains 1.30 moles of calcium 2 plus ions. And we want to know the total number of metal ions that will exist if we dump these two beakers together, so we form just some sort of mixture of these two solutions. So you can figure out the total number of moles by simply adding the number of moles in each beaker together. So that's what you do in this first step up here, 0.250 plus 0.130. From there, after you get the total moles of metal ions, you can use Avogadro's number, right, this 6.02 times 10 to the 23rd, to go back and forth between moles and ions. So that gives you your final answer for number 97. In number 99, we're working in the opposite direction. So in this case, you start off with molecules, and you want to go from molecules to moles or something. So you're told that a snowflake contains 1.9 times 10 to the 18th molecules of water, and you want to know how many moles that is. In this case, you set up your conversion factor again. So you set up this Avogadro's number here. And you want to cancel out molecules, so in this case, 6.02 times 10 to the 23rd molecules is in the denominator instead of the numerator. If you set up your conversion factor correctly, right, your molecules will cancel out, and you'll be left with moles. You'll get your final answer. Number 115, we're adding another step onto this. So in this case, we're starting with a mass, and we want to go all the way from mass to atoms. Again, atoms we could consider a type of particle. So you need to make two conversions to do this, because we don't have a direct conversion between grams and atoms. You can use molar mass to convert back and forth between grams of something and moles of something. And from there, you can use your Avogadro's number to go from moles to atoms. So we've got two conversions here, right? This first one that goes from grams to moles, and the second one that goes from moles to atoms. We've got our two conversion factors, and it's just a matter of figuring out how to arrange those conversion factors to cancel out the units we want. So to cancel out grams of silver, we want our grams in the denominator, so we want to divide by molar mass in the first step. In the second one, we then want to cancel out moles. So if we want moles to cancel out, we need moles in the denominator and atoms in the numerator. That will give us our final answer here, 6 times 10 to the 13th atoms. Okay, in number 120, we're adding another layer onto our existing framework. So in this case, instead of starting with just a mass of argon, we're starting with percent by mass. And it's important to remember the percent by mass formula in order to solve this problem. So you can look at the formula. So percent by mass equals the grams of the part over the grams of the whole thing times 100%. In the case of what we're doing here, right, the part is argon, and the whole is air. We're given a mass of air, there's 0.6 grams. We're given a percent by mass, so we can use that to get our grams of argon. Once we get grams of argon, we can then do something similar to what we did in number 115. Use the molar mass of argon and Avogadro's number to solve for our final answer. So once you determine this grams of argon using the formula percent by mass, you start with that, use your molar mass to cancel out grams, use Avogadro's number to cancel out moles, and it'll give you your final answer, 8.44 times 10 to the 19th argon